Africa is undergoing a dramatic transformation, one so extraordinary that it's reshaping the very fabric of the continent. Beneath East Africa, the Earth's crust is breaking apart as the Somali and Nubian tectonic plates pull away from each other. This phenomenon is expanding a rift that, in time, will give rise to a new ocean, altering the geography of the planet. What's happening in Africa is nothing short of a geological revolution, and it's a story of immense power, destruction, and creation. The event that triggered global awareness: the 2005 Dabahu eruption. In September 2005, the Dabahu region in Ethiopia's Afar Depression became the epicenter of a series of alarming seismic events. Within a single week, over 130 earthquakes shook the area, signaling a massive geological shift. Communities were caught off guard as the ground beneath their feet trembled and cracked. For many, it seemed like the earth itself was rebelling. On September 26th, the Dabahu volcano erupted, releasing ash, molten rock, and gases into the atmosphere. Though not explosive by global standards, the eruption was a defining moment in geological history. It caused 37 miles of fissures to tear through the Earth's surface, some so deep they revealed molten rock below. The land displacement was staggering, with sections moving several meters in just a few days. The eruption forced over 6,300 people to flee their homes and devastated local agriculture, creating a humanitarian crisis. Yet, amid the chaos, scientists recognized a unique opportunity: the chance to observe the birth of a new ocean. The East African Rift is one of the most striking geological features on Earth. Spanning 3,000 kilometers from Ethiopia's Afar Depression to Mozambique, it marks the boundary between the Somali and Nubian plates. As these plates drift apart, the Earth's crust is thinning, forming valleys, fissures, and escarpments. This dynamic rift is unlike other tectonic zones due to its activity occurring on a human timescale. Magma plays a crucial role in this process. Rising from the mantle, it creates pressure that pushes the plates further apart. Over time, this thinning crust will give way to a new ocean basin. Evidence of this is already visible in the Afar Depression, where parts of the land have sunk below sea level. The future: a continent split in two. Eventually, water from the Red Sea and the Indian Ocean will flood the East African Rift, splitting the continent into two regions. The Somali Plate will form a new landmass, creating coastlines bracketing a newly formed ocean. This transformation is reminiscent of the breakup of the supercontinent Pangaea, which gave rise to the Atlantic Ocean around 180 million years ago. The implications of this shift are enormous. New ecosystems will emerge, marine biodiversity will flourish, and human populations will need to adapt to the changing landscape. However, the process will also bring challenges, including displacement, intensified volcanic activity, and altered climate patterns. The movement of tectonic plates is a fundamental geological process that has shaped the Earth's surface for over millions of years. These massive, rigid slabs of rock, which make up the Earth's lithosphere, are in constant motion, driven by the forces generated deep within the planet. But scientists have discovered a colossal fissure tearing through the southeastern part of Africa that is splitting the continent into two, and could also pave way for the Earth's sixth ocean to emerge. The planet currently has 5 distinct oceans: Pacific, Atlantic, Indian, Antarctic, and Arctic. A sixth ocean, if formed, could lead to massive changes in the planet's geography. Known as the East African Rift System, EARS, it was first discovered in 2005, but believed to have initiated around 22 million years ago. However, a significant surge of activity over the past few decades has spurred a renewed scientific interest in the fault line. The East African Rift is a result of 2 tectonic plates, the Somali Plate in the east and Nubian Plate in the west. These two tectonic plates have been drifting apart, causing the fissure to deepen. A glimpse into Earth's future. The East African Rift offers a rare opportunity to witness geological processes that typically take millions of years. From the 2005 Dabahu eruption to ongoing seismic activity, it's a vivid reminder of the immense forces shaping our planet. While the birth of a new ocean may take tens of millions of years, the journey has already begun, and it's rewriting the map of Africa. Geological transformations can reshape continents, ecosystems, and even the trajectory of human civilization. In the heart of East Africa, a profound natural process is underway that could forever alter our planet's geography and climate, the East African Rift. This rift, driven by tectonic forces, volcanic activity, and crustal deformation, is splitting the African continent apart, setting the stage for the creation of a brand new ocean. The terrifying scale of this transformation and its ripple effects on ecosystems, communities, and global systems cannot be overstated. The potential formation of a new ocean in Africa was brought to the world's attention back in 2005, when a massive crack was observed within the Afar region, specifically in a desert in Ethiopia. Scientists and geologists predict that the crack, which spans approximately 40 miles at the time of this writing, is the tangible evidence signaling that the African continent is being separated into what will eventually become smaller landmasses. Assuming it will be called the African Ocean, this new ocean in Africa will reshape and redefine the geography of not only Africa, but also the entire planet. The map of the world, as we see it, will look much different if this new ocean forming in Africa comes to fruition millions of years from now. Scientists and geologists are studying the East African Rift not just because they consider it to be a rare geological phenomenon, but also because they want to better understand both the benefits and the repercussions of this new ocean in Africa. They won't see the African Ocean in their lifetimes, of course, but the real-time measurements and observations they can gather with today's technology will allow them to gain valuable insights into the long-term processes of rifting, plate tectonics, and so much more. Behind Asia, Africa is the second biggest continent in the world. The fascinating geological changes taking place in Africa remind us that change is constant and, on that note, imminent. Just as the Earth is spinning at a rate of approximately 1,000 miles per hour, the ground is moving beneath our feet. It's hard to fathom the depths of the ocean and the vastness of space, but we must acknowledge that we're not, by any means, living on a stagnant planet. The forces behind the rift. The East African Rift is a dramatic testament to the Earth's restless energy. Here, the Somali Plate and the Nubian Plate are slowly drifting apart, creating fault lines, fissures, and volcanic eruptions that redefine the landscape. Beneath this rift, magma wells up, causing seismic activity and crustal deformation. These tectonic forces are not isolated. They intricately interact with surface processes, reshaping ecosystems and challenging communities that call the rift region home. Understanding the mechanics of this process reveals a stark reality. Earth is not static, and its immense energy has the power to reshape continents. But how does a rift transform into an ocean? The journey from rift to ocean unfolds over millions of years through distinct stages. 1. Rift to valley tectonic plates diverge, creating fault lines and fissures. Magma rises, driving volcanic activity and earthquakes that deepen and widen the rift valley. Steep cliffs form along the edges, giving rise to elongated depressions. Second, valley to gulf. As the rift deepens, parts may sink below sea level. Water from nearby bodies, like the Red Sea, begins to seep in, forming isolated gulfs or narrow waterways. The Afar Depression is already showing early signs of this stage, lying below sea level and demonstrating water intrusion. 3. Gulf to ocean basin. Over millions of years, continuous tectonic activity widens the Gulf into an ocean basin. Magma forms new seafloor, and the rift transforms into a mid-ocean ridge system, creating a fully fledged ocean. While the process appears slow on human timescales, scientists estimate that a new ocean will form in 5 to 10 million years, with plates separating at a steady rate of 2 inches per year. Similar processes created the Atlantic Ocean after the supercontinent Pangaea split apart, demonstrating the long-term geological blueprint being followed. Jerusalem posts that a similar phenomenon was observed millions of years ago when South America and Africa were divided into different continents. A peer-reviewed study detailing the split was published in Earth and Planetary Science Letters. It said that the plates separate a few millimeters per year. Interesting points have emerged from the deepening fissure. Experts say that countries currently landlocked in Africa, such as Ethiopia and Uganda, will see the introduction of a coastline. Advertisement. The Gulf of Aden and the Red Sea will flood in over the Afar region and into the East African Rift Valley and become a new ocean, and that part of East Africa will become its own separate small continent. Ken McDonald, a marine geophysicist and a professor emeritus at the University of California, told Mashable, "As the Somali plate separates from the African mainland, a new island will emerge. This landmass, comprising parts of Ethiopia, Somalia, and Djibouti, will eventually be surrounded by the new ocean, resembling the separation of Madagascar millions of years ago. Meanwhile, countries like Kenya and Tanzania will witness their coastlines transformed, with dramatic implications for human settlement and biodiversity. Ecological and climatic impacts. Major geological events like the formation of a new ocean disrupt ecosystems and climates. The isolation of land fragments encourages species to evolve independently, creating biodiversity hotspots. Coastal zones bring new weather patterns, potentially altering rainfall distribution and agricultural productivity. Historically, such transformations have reshaped global climates. For instance, the rise of the Isthmus of Panama 2.8 million years ago redirected ocean currents, triggering ice ages in the northern hemisphere. Similarly, the East African Rift's ocean formation could redistribute heat and moisture, causing regional and global climate shifts. Harnessing technology to understand change. Modern technology offers unprecedented insight into the East African Rift's progression. Satellite imagery, GPS systems, and seismic networks are tracking tectonic shifts, magma movements, and ground deformation in real time. Innovations like AI-driven data analysis and autonomous drones are expanding our understanding of this geological marvel, ensuring humanity is better prepared for its long-term effects. Adapting to the rift communities living in the rift region have developed ingenious strategies to adapt to this dynamic environment. In the Afar region, locals use geothermal steam vents to condense water, addressing the scarcity of fresh water. A volcanic glass or obsidian is tested for safety before being crafted into tools, showcasing remarkable resilience in the face of environmental challenges. Additionally, the rift's geothermal energy and mineral resources provide economic opportunities. Countries like Ethiopia are already harnessing geothermal energy, paving the way for sustainable development. A terrifying yet transformative future. The East African Rift serves as a stark reminder of the Earth's incredible capacity for change. While the formation of a new ocean may seem distant, its impacts on ecosystems, communities, and the global climate will unfold over time, reshaping the course of history. By understanding and monitoring these processes, humanity can navigate the challenges and opportunities presented by this extraordinary geological event. As technology advances, we are uniquely positioned to witness and adapt to this unfolding story, a narrative of transformation that will define the next chapter of our planet's evolution.